So now that we have a basic understanding of how to work with percents, as in converting them to decimals or fractions, we want to see how do they show up in many problems. So here's an example. We got a restaurant that's running a fundraiser, and they're going to take 30% of every purchase and donate it for food relief. So the author and his wife spent a total of $24.59 at the restaurant. How much is going to be donated? Well, if you notice, he says that there are some words in mathematics that mean particular things. So of is multiplication. The word is would represent an equal sign. And we could look at this blank here where we'd say 30% of the amount they spent, $24.59, is what amount? So what is the amount that we're donating? Well, when we're talking about 30% of this total, we're really saying multiply this total by 30%. But we can't multiply by 30% because that has a hidden operation. This really means 30 divided by 100, like we talked about before. So if we want to multiply 24.59 by this percentage, we would need to use this form, the fraction, or the preferable form, 0.30. So to do that, we would just take our 24.59, and the units there are dollar signs, and we're going to multiply it by 0.3, and that's going to get our value. So let me do this in Desmos. I'm going to do 0.3, and I'm going to hit the Shift 8 button to put in multiplication, and then I'm going to type in my 24.59, and there is our value, 7.377. This is the amount. So how would we round that? Well, depends on what you're working with. Now, I would guess that this restaurant is going to donate $7.38 because we don't really have a currency of 7/10 of a cent. Now, if you go to the gas stations and you fill up, you'll see that they often have $2.99 is the price per gallon, and if you're paying real close attention, $2.99 and 9/10 of a cent. So really, it's $3 because this is essentially 1 penny. It's not, and when you're paying with a credit card or electronic version, we can keep track of those amounts, those non-physical forms of money. If you tried to pay a 7/10 of a cent, how are you going to do that? You're going to chop up a penny into 10 equal parts and then give them 1/10 of it. I think isn't that illegal to do anyways? So this is what we would round to. That would make the most sense. Sense, right? And in general, in this class, if I don't tell you what to round to, you round wherever it is appropriately. So here's the rule. If I'm going to round to what's called 2 decimal places, which is what I did in this problem, or we could say round to the nearest hundredths. Oops, I need a thufs. Hundredths. Then we're going to go to the second decimal place. So this is where we're rounding to. We look at the number immediately after it, and we say, is this a number 5 or greater? If it is, we add a 1 to the number here, which is why this became an 8. If it's less than 5, so 4, 3, 2, 1, or 0, we just simply drop the number off and leave it. We would leave it as the 7. For example, if it had been $7.37 3/10 of a cent, this would round to 7.37. The idea with that is that a 5 represents being halfway there. So if we're at least halfway there, we round up all the way there. Notice this symbol as well. This is the approximate symbol. And it signifies that the value we have written down is a rounded value. So really, I should have used the approximate symbol here. All right, let's do one more problem here. So we can do the same idea for other calculations with percents, as we're talking about here. So we've got a closeout store is advertising leather jackets at 70% off the original price, which means the sale price is 30% of the original. Now notice That's a tricky fact, right? So if we start with, if we write these things out, we've got the original price is 100%, right? So that's original price. And then we're going to be offered a 70% discount. So this is a 70% discount. That means if I subtract the 70% discount from the 100% of the original price, we get a 30% is the new price, meaning 30% of the original. Which is precisely what he's saying here from the blanks. 30% of what amount is, and then notice we're told that if one jacket has a sale price of $59, how much would it cost originally? So this is the amount you're paying at the cash register. In other words, we had 30% of the original amount when we did that multiplication. We'll call this original. We ended up with a final price of $59. Excuse me. So we got to do the old thing we did before. We've got to convert this percentage into a usable number, or just, we have to keep track of this symbol means divide by 100. Again, I think it's easier to work with the decimal, especially if it's less to type into Desmos if you're using Desmos. And if we think through what we did in this previous problem above, where we did 0.3 times 2459, we would do the same thing here. We would say 0.3 times the original price. Let's call that X. And that's going to equal the new price we're paying, $59. Well, for those of you that love algebra, you'll know that the way to solve for this is to divide both sides of the equation by 0.3. All right, so that becomes 1, and we get that the original price is whatever this is, $59 divided by 0.3. I'm not going to try to do that in my head. I might be able to, but I'm not going to bother. I don't want to embarrass myself. I'll just run over to Desmos and do 59 divided by 0.3, and there we get it. So 196.666666666 and 7. What's happening here in Desmos is the value here is 0.6 repeating forever, and they're just rounding at this very last decimal place here. They're rounding that up to a 7. So let's go ahead and write that down, that this is equal to 196.6666. I'll just write 4 of them. Often, you may remember this from olden days, the bar over the numbers means this continues to repeat forever and ever. Amen. Well, we're working with money, so it would be most appropriate, again, to round to 2 decimal places, or the 100th place. So this is the number we're working with. Look at the number immediately after it. It's a number larger than 5, so we would round this to $196.67. That is the original price.